Good afternoon, everyone. Welcome back to another episode of Dojo Live. Today is Wednesday, January 5th, 2022. I'm Tulio Siragusa, broadcasting from Southern California. And joining me today is Kim Lantis in Hermosillo, Mexico. Hi, Kim. Welcome back.
Carlos, hey.
You're channeling Carlos with your muted button on. And then we have our guest, Gary Saarenvirta. Did I say that correctly?
Yeah, you said that very correctly. It's a Finnish name. So most people say Cernvirta, but Saarenvirta is the Finnish pronunciation.
Saarenvirta. Okay,
good. Points
for me. Who's the CEO at Daisy Intelligence? Well, to be fair, what I did is I just read it in Italian. Saarenvirta, which that's how I did it. I thought it was Italian, but here we go. It's Finnish. So welcome, Gary. It's good to have you on the show. Today, we're going to talk about AI again. We have a lot of shows to talk about AI, but this specifically about how to elevate decision-making process around services with a focus on innovation. So before we get into the topic, let's get to know our guest a little bit. If you could introduce yourself, Gary, we would appreciate it. And again, thank you for being on the show.
Thanks. Yeah, I'm Gary Saarenvirta. I'm the founder and CEO of Daisy Intelligence. I'm a tennis fanatic, so I play tennis every day. Keeps me healthy and fit. I have 3 kids. I lived in Canada most of my life, and have a graduate degree in aerospace engineering, and backed into this accidental career of bringing more math and science to business. In Canada, where I graduated, there wasn't much of an aerospace industry. Didn't want to leave Canada to move to the United States at the time, and so I started working with big corporates and was shocked at how little math and science they used to make operating decisions. And so I created this career for myself for the last 30 years and founded Daisy Intelligence about 15 years ago, and been having a blast for the last 25 years applying technology and trying to make the world a better place.
Well, we're literally talking to a rocket scientist, so having a blast is very, pun intended, right? So good to have you as our guest. Tell us a little bit about Daisy Intelligence. You started this 15 years ago. What was that moment where you're like, I got to go do this? Tell us a little bit about that.
Yeah, I mean, about 25 years ago, when I went to University of Toronto, that's where, Jeffrey Hinton, one of the founders of deep learning and AI, went, and I attended a lot of his lectures and seminars, and been playing with this machine learning technology for about 10 years. I think the world is having the moment now that I kind of had by myself like 25 years ago, and spent 5-10 years trying to apply machine learning in this kind of current form to business, and found it didn't quite work. And so I kind of mixed in some of the aerospace stuff we do. The aerospace industry has been doing kind of autonomous AI systems for decades. Neil Armstrong didn't really land the lunar lander on the moon. I mean, he gave the computer the objective, what he wanted to do, and the flight instructions, and the computer actually executed the gory details. And so I thought, trying to bring that model to business, that was the kind of aha moment when I found that, predictive analytics or, machine learning, whatever, the hype, the terminology has changed every 5 years it changes, but the technology really hasn't evolved that much. So I thought kind of mixing aerospace, what the aerospace industry has done to business, that was kind of my aha moment. I was running IBM Canada's data mining and data warehousing practice at the time. And I thought that I had some expertise in this field, and, IBM's a great company, but, they're good at everything, maybe best at none. And then, so I thought I could do this better than IBM, and really had a passion to help companies operate smarter, make more money. And if we help our clients improve their profitability, smart companies don't bank the money. They reinvest in price and innovation. So that means it lowers the cost of goods and services for you and me. And I thought if I can make every industry smarter, then that would lower the cost of living for humanity, and maybe help put a small dent in poverty. That was the kind of dream. And so I've been trying to help companies be more efficient, more profitable using AI. And that's what Daisy does. And so we're we're an autonomous AI. We deliver decisions. I think that's we do what people can't do. So that analogy of Neil Armstrong not being able to fly the lunar lander because it's beyond human ability. The computer making minor adjustments to control jets, 1,000 times a second. That's beyond human ability. And so in the same way in retail, deciding what prices to charge at 400 stores for, 100,000 products at 400 stores, it's impossible to come up with the optimal price mix for millions of products, or to decide what thousands of products to promote every day. These are decisions that are, beyond human ability. And so the technology can help make those decisions, make an actual recommendation that the human doesn't have to be involved in that. And by freeing the people up from that drudgery of making those gory decisions, people can do what people do best, which is innovate, figure out how to service customers, focus on strategy, and let computers do what computers have always done, which is compute way faster than people can and do what people can't. And so that's our goal, elevate people. And by doing that, those employees can then help the company be more profitable, deliver value to their customers. Hopefully we improve employee satisfaction. And so we call that kind of explainable decisions, deliver decisions that make sense and have an explanation. So it's not just a black box.
Yeah, that's amazing. So many variables, and you're right. The human capacity, you need an army of people to analyze and execute on all those variables, and sometimes you can't even accomplish that. Let's go right into the topic today and see what we can unpack and what we can learn today. Kim, would you kindly introduce the topic and kick it off?
Of course. Thank you, Tulio. Thank you, Gary. So, Gary, the topic as chosen by you today is AI that delivers explainable decisions as a service. More specifically, how AI-powered explainable decisions as a service elevate the role of the human in the workplace to enable employees to focus on innovation, strategy, and servicing customers in retail and insurance. Now, I think you've pretty much covered that very well with your explanation of your background as well as Daisy. What I'd like to dive into a little bit is the title here with explainable decisions, a little bit more about how that's accomplished, because a lot of the times, at least this is my impression, when we have technology that pulls together this big data, it's like, here's the data, and then there's that blank of, okay, thanks, what's next? And I think that it could still be overwhelming. So it's my understanding that what you're doing is kind of helping provide that's what next is actually something that's actually actionable for me. Is that correct?
Absolutely. And I think the big difference in our approach is, again, borrowing from the field of science. In the last 300-400 years, the scientific method was not collect data and then assume that explains how the universe works. Now, that's not how science is done. The scientific method is come up with a theory, an explanation as to how the world works. And when you have that, then you go collect the data that's needed in your explanation or your mathematical theory, and you test it and you iterate it. We seem to have this idea of big data and machine learning has turned that inside out, and that's wrong. And so what we've done is applied that same approach. Like we've created a set of laws of business, like the laws of physics. And there's an explanation, the laws of physics. There's an explanation as to why those laws work, how we can use it to, calculate black holes colliding now, the latest things with Einstein's theory of relativity. So we've created a similar set of mathematical equations, and then we apply that to business, and there's an explanation. And so when you're making a recommendation, let's say in retail on what product you should promote, or in insurance, whether you should pay a claim or not, whether it's fraudulent or not, you need to provide an explanation to the people who are looking at that to say, why is that price? So we would say promoting this product is a good choice. It's the right product because it has a large use case. A product like ground beef, nobody eats raw ground beef. Everybody will buy something else with it. If you're making a pasta dinner, you'll buy pasta, tomato sauce, maybe a bottle of wine, cheese, salad fixing. So the explanation is ground beef is a great product because it has a large halo. And it's the right time of year. People are making pasta in the fall. It's a good time. It's a better price point than you normally do. And when you promote it on the front page of your website or your flyer, that's the right place to put it. So the explanation why we're suggesting the way to promote it, that's the explanation that gets the human being to say, oh, that makes sense to me. It's the right season, the right price point, the right promotional placement. It's a good product. It's better than other products. So that's the explanation. You can't just assume a person will take a recommendation as a black box. There's no trust. And so by explaining why the AI is recommending that, then the human starts to trust. And when they realize all the explanations are just all the common sense things that they know, but just because there's billions of patterns, the human being can't find all of that, right? And that by explaining, we build trust. And so that's the most important thing. I can't expect human beings to trust a system unless you can explain why it's making this, like the suggestions it does. And so I think explainability is huge to build trust in AI across all industries. We won't adopt AI to its maximum until we can explain why it's making the recommendations it does. And so that's kind of a long-winded answer. I mean, the key thing is to have a theory that you can explain, right?
No, that makes perfect sense. Like going back to the basics, making it simple. Everyone, I mean, from elementary school, you're learning about a hypothesis, right? And to prove or disprove your hypothesis. So I think that's incredibly relatable, incredibly smart. I get it. I completely get it. So what about, go ahead, Tulio.
No, go ahead, finish.
I was just going to ask, you mentioned this both in your tagline and now, retail and insurance. Why did you choose those two verticals specifically?
I think retail for one is great. I mean, huge volumes of data. As an aerospace engineer, I had this technical desire to do something really technical, and so retail, because it has a huge volume of data, grocery retail collects terabytes and terabytes of data. So I thought that was a real technical challenge, was meaty for me to sink my technical chops into. And I thought we can all relate to food. We all have to eat. And I thought that was an area to work on. And then in insurance was, I thought fraud happening in insurance is a huge problem. The cost of insurance has continued to rise over the last 25 years, largely due to fraud. And the fraud is funding crime and the criminal element and terrorism. And I thought eliminating fraud would be another great societal impact. And so on the surface, they seem like two wildly different things, but at the end of the day, it's doing something that's beyond human ability, that's highly mathematical. Both have, we have a theory of business underlying that's common to both of those things. And Daisy's really about automating processes and automating that decision making. So they're actually quite similar, right?
Yeah, and it goes back to the overall mission that you mentioned at the very beginning of the show of wanting to ultimately lower the cost of living for individuals. And yeah,
absolutely. And our plan is to go to every industry eventually as we grow. We want to be in all industries, because in every industry, there's all kinds of decision making that happens that's beyond human ability. That's highly complex, very mathematical, and I think that's where technology can help people, right? And
I was curious about. I get retail, a lot of volume. You need many variables and lots of data for at least machine learning to be effective. Insurance seems to be less than that in terms of volume and activity. How did you make that work? I'm curious, did you crack the code on being able to use the algorithms for lower numbers of transactions and to look for anomalies or look for, variables that can be utilized more effectively? Because I remember that was one of the challenge with at least machine learning was you needed massive amounts of volumes of data in order for the algorithms to actually work properly. I'm just curious, from a flow of data, these are two different sets of businesses. What's unique about Daisy Intelligence that allows you to have these disparate industries that you're serving?
Well, we don't learn models from the data. That's not the scientific method was to invent a mathematical theory. So we've invented differential equations like the laws of physics, independent of the data. Before we collect any data at all, We come up with a differential equation like the general theory of relativity or Black-Scholes in finance. And then the historical data is used to configure the simulation. So if I was to give you an analogy of an autonomous race car, you wouldn't build a physical race car and say, hey, put it on the track and say, learn how to drive, right? There's no predictive model. There's no labeled data that says, how do I get around Laguna Seca racetrack that, you know, that this was a good millisecond, bad millisecond. You don't label the data. That's all a myth. What do you have? You have the laws of physics, right? And so you would train the brain of the car in a computer simulation. So it says you have to have a simulation of the world, and the simulation of the world is the laws of physics. The historical data that you have is used to configure the simulation. So in the case of the racetrack, it's the air density, the gravity, friction of the rubber on the road, the track configuration, and then you configure your differential equations and you say, what's the optimal sequence of decisions, which is steering, brake, and gas pedal that get me the fastest lap around the racetrack. And so the analogy in business is a lap around a racetrack is like a year of business. To drive a retailer, it's the weekly sequence of what products to promote, what products not to promote, what prices to charge, how much inventory to allocate. That's how I drive a retailer. To drive an insurance company, it's the weekly or daily premiums that I underwrite. It's whether I decide to pay a claim or not, to adjudicate them, and the fraud detection. Those are the important decisions that drive an insurer. So we've come up with some differential equations. And retail is an interaction-dominated business. You know, the ground beef pasta, you know, has a lot of interactive effects that go on. And insurance is an outlier-dominated business. And all human decision-making is a combination of those two things. It's either an interaction decision or an outlier decision. So insurance is outlying, medicine is outlying, you're different than the norm. If you're different than the norm in insurance, you're risky or fraudulent. If you're crossing the border, you could be a terrorist. That's different than the norm. Cybersecurity, that's different than the norm. So outlier decision-making is one type of decision-making, and interaction, you know, decision-making is another. And so combining those two together with retail insurance, we've got both types of decision-making that we can now apply to all industries. And so that's our underlying theory covers that interaction and outlier effect, and that's our differential equations. And then the final thing is, if I make better decisions today than I did yesterday, I will have better outcomes. You know, that's the differential. Right?
Talking about variables, are you having to take, I mean, I don't know the reach yet of Daisy as far as like regions, countries, language, but are you going to be adding, or do you add in like cultural variables? I mean, obviously what we eat or consume in the United States is going to be different than what's happening in France or China. Different holidays. What type of human variables need to be taken into consideration?
Except for pasta, everybody eats pasta.
Well, the system learns. You know, the system learns from the transaction. So we have clients in the United States, Canada, in the Middle East, in Europe, and the system doesn't know anything at the beginning. It can see the pattern. So when we see what are people buying in the transaction, we can look at the combinations of items that occur together. So you can see that ground beef example, pasta, for example. We know that you go North America, the further north you go in the United States and Canada, the more east, you know, the number one produce item is bananas. You go to the west and the south, it's avocados. In the United Arab Emirates, the number one produce is tomatoes, right? And so the system just sees that in the data, and it doesn't know that a tomato is a tomato. It just sees a barcode or a UPC number, and it knows that this item drives a large halo. It occurs in lots of different patterns, and that's what the theory of retail is. It looks for items that have a large halo. Then we know that items cannibalize because you bought ground beef to make hamburgers. You didn't buy sausages and hot dogs. So that's a negative effect. Because in the halo of ground beef to buy hamburgers, you bought buns, hamburger buns. You didn't buy hot dog buns. That's cannibalized. Because it was on sale, you pulled forward. You bought more than you needed for the week. You bought it on sale. There's seasonality. What people buy at Christmas time is different than they buy in the summer. what you bought last week impacts what you bought this week. When things are on discount, you buy more. These are all the common sense features. And the system just looks at each client is like a new universe. And we learn what are the constants in that universe. And we find all the cultural patterns, the holiday patterns for all religions. We have, a client in Bosnia where they have every religious group there in fairly large numbers. So we see the Ramadan purchases and the Easter purchases and so the system can see all of that on its own without any human tuning at all. We don't have data scientists who build models at Daisy. Our mathematical theory is like the laws of physics, and it works. It fits the data and can see all of that from the transactions.
So Gary, did you see the toilet paper crisis coming?
I mean, there's no omniscience, right? But as soon as we saw, 1 or 2 days of transactions, because although you saw sales changed, the recipe for pasta bolognese didn't change. What you do with toilet paper didn't change. So the human usage of products did not change at all during COVID. Maybe we found a few new use cases, but the vast majority of things were unchanged. And so when we saw the mix of patterns change with literally 1 day of transactions, we could then see, hey, the mix of products have changed. And so we know that if toilet paper sales go up, we know all of the halo products that will be dragged along with toilet paper as well. And so it wasn't that we could predict that there would be a run on toilet paper, but as soon as it happened, I didn't need 2 years of history like you need for a predictive model to have nice longitudinal history, because what was constant was our seasonality. Seasonality was stronger than COVID, right? You still bought a turkey for Christmas dinner, whether it was COVID or not, right? You might have bought more toilet paper than you normally did, but your normal seasonal patterns. So all of those human patterns still dominated even though COVID happened. And so using a scientific approach that has a theory that explains how things work, it doesn't need that machine learning. It's not a data-driven exercise. And the world isn't a data-driven exercise. I think this sea hunt for data, to be honest, will go away because it doesn't really work. There's a very narrow number of use cases that it actually works for. And I think the approach I talk about is going to be the one that's going to dominate. And I've already seen inklings in other academia and academics talking about this approach and been applied in the aerospace industry.
So Gary, it sounds like you have created a very scientific approach to solving common problems that require the ability to analyze massive amounts of data and come up with resolutions or recommendations to make explainable decisions. So that's fantastic. And it looks like retail and the insurance is your first 2 verticals. We're just curious a little bit as we shift a little bit as we get toward the end of the conversation today. What kind of people come work for Daisy Intelligence? What's the day in the life of an employee there? What's the culture like? If you could go into that a little bit.
Yeah, I think people buy into the vision. I'm, very blessed that I have people who buy into the mission that we have, which is to make the world a better place, elevate humanity. We don't want to replace people. Technology shouldn't replace people. So I think our employees are ones who like that vision. The opportunity to create technology. So we are creating technology at Daisy with our own scientific approach. There's no open source software that does. So if you like to create new technology and have the opportunity to do that, because we're a small company, when you write a new piece of feature in our software, one day, the next day you see that our customer, and you can see the impact that your work has. So our employees will see the immediate effect of their great work and the impact it can have on our customers. So that being able to close the loop, which is harder in larger companies, not to denigrate big companies, but if you're one of 50,000 employees, it's hard to see what impact your work has. But in a small business, you can have that impact. It's a scaling company, so the work is hard. There's a lot of work. We're a family. I think we treat our employees very well, and we do our best to make it a great environment and be as flexible as possible, especially during the pandemic. It's been a really tough 2 years. So I would say our employees really, buy into that vision, love to see the direct connection between their hard work and the outcomes, and the ability to impact customers. And we have a huge financial impact on our customers, and that's really rewarding to see that. So I think it's an exciting place to work, and I think we offer some unique challenges that you can't get anywhere else.
So you came from a pretty large company at IBM, where let's say you carve your teeth there, right? Your early career. What was the transition like going from a well-established large organization to starting your own company? Was there a learning curve for you as an entrepreneur in that process? What was that like?
Yeah, absolutely. I mean, I was always fortunate that I always ended up running a P&L wherever I was. And I worked at the University of Toronto as a research scientist and ran a small research budget of, $5 million. And then did a software company with my buddies after we graduated, and then went to IBM. And so I always ended up kind of running a P&L in a small business. So I think that gave me the kind of corporate accounting stuff, which you don't typically learn too much of that in engineering. But the learning in business, some of the things I learned a lot, and I continue to learn to this day. I think that so the transition of the financial management is the hard thing for technical people, and I think learning that cash is king. It's not revenue or profit that matters; it's cash burn and the ability to fund continuing operations. That took a long time to learn. As I continued to, for many years, I funded the business for 12 years by myself. Through the revenues we generated, and learning that it's all about the cash, and all these metrics that people quote, revenue and profit. Those are, they're important, but having cash, and then learning how to motivate people. As a technology person for the first, 3/4 of my career, it was all about technology and finding people with capabilities. And then in the last, I'd say 5-7 years, it's all about the human element of it too. It's like, how do you motivate people, and how do you allow them to grow? And I've really focused a lot more on the human element in the last 7 years, and learning more about that, because having great technical chops that's a commodity. I think having great attitude and personality and desire to learn and those human elements are even more important and are rarer than the technical skills. So I think it's been a real evolution for me personally. If you talk to my wife, she's been bugging me for 15 years about this, and she's saying, finally, you're coming to realize that the human element is more important than your science and math, which I spent the better part of my life focused on, right? So.
Yeah, that resonates with me. I spent the earlier part of my life gaining knowledge, thinking that would help understand people, and then thought, well, if I develop wisdom, that'll help me understand people, and then eventually realized it's really all about empathy. And
it is, yeah.
Even in the design thinking work that I do, it's what feeling is this going to create for people, and that's not logical or scientific, to be able to explain emotions. So congratulations.
Sure. I'm a work in progress. Work in progress in the area, trying to do better.
Aren't we all? Yeah. So what words of advice would you give for people who might have a highly technical background, whether they're a scientist or an engineer, and want to go down the path of building something that actually will improve the lives of many people through your own lessons? What would you tell them to do earlier on versus later in their journey as an entrepreneur?
Yeah, I would say you'll like learn about some finance, like how to do corporate finance is important if you're going to run a business. A little bit of that, or find a partner whose passion is that. Either you learn it or find a partner. I think focus on that human element, learning about what makes people tick, and having empathy and understanding that everyone is different, and understanding what motivates people. I think those are important elements to learn early on, and then not be in a headlong rush. That this idea that you can build $1 billion business overnight. The average software company to get to $1 billion valuation, it's something like 17 years, right? It's a long time. It's those companies that become $1 billion overnight. Those are 1 in a billion companies, right? So having the attitude that it's a long-term journey. And the exit for me is an anticlimax. The journey has filled my life with purpose. I've met amazing people. I've been able to employ people, which is a great honor, and I take that as a great responsibility. So I think having this view that life is a journey and it's not about the exit. It's about building a great business and a great team. And I think not being in a headlong rush. I think young people today, I see they're in such a rush, and I think that I'm doing this for 6 months. Now I'm an expert. I can move on. It's like, no, you got to be patient and have perseverance and dedication. I think those are the things that I've learned that have served me well. And I think that I share with young people. And I think young people are great, the energy, vigor, but don't be in such a rush. Life is long and you have lots of time, right?
Hold off on your G5 order. Give yourself a little time.
Exactly.
And on that, we'll call it a wrap. It's been great speaking with you today. Thanks for sharing this with us. And thanks for sharing yourself and what you've personally learned. We really appreciate that. We hope that others who are on the fence about maybe pursuing an entrepreneurial venture can learn from these lessons that you've learned and shared. So thanks for being with us. Just stay with us as we go off the air in just a second. Can we have one more show this week, right? Tomorrow? What do we got coming up?
That's right. We sure do. We're going to be speaking with Prasnath Nair, who is the CEO and product architect at Double Gemini. And we're going to be talking specifically about ending email overwhelm and answering the question of why is email making you less productive and what you can do about it. So don't miss it. Tomorrow, 12 o'clock Pacific on Dojo Live. Thank you so much, Gary, for being here, Tulio also, and have a great rest of your day, everyone.
Awesome. Thanks so much.
Thank you.
Take care.